Now, the molecule in which halogen is attached to sp hybridized carbon atom is. The options are as follows. In this, the molecule in which the halogen atom is attached to sp hybridized carbon atom, the sp hybridized carbon atom is the carbon which is bonded to other carbon by a triple bond, right? So if it is a double bond, it is sp2 hybridized carbon atom. So option A is wrong. In option B, the carbon is sp hybridized, but the halogen atom is attached to sp2 hybridized carbon atom. So option B is also wrong. In option C, it is again a double bond, which means sp2 hybridized carbon atom. So option C is wrong. So it should be option D. Let's see option D. The carbon is bonded to other carbon by a triple bond and halogen atom is attached to that carbon. So option D is the right answer, and here I means iodine, right? Iodine. So which is a halogen. So option D. The compound which is not an allylic halide is. The options are given as follows. An allylic halide is an halide in which the halogen atom is attached to a carbon atom which is further attached to a carbon-carbon double bond or a double bonded carbon atom. So, in this option A, halogen is attached to a carbon which is further bonded to a carbon-carbon double bond which is an allylic halide. In option B, the halogen is attached to carbon-carbon double bond. So we can consider option B also as an answer if there are multiple options, right? So next, even option C is an allylic halide because the halogen atom is attached to a carbon atom bonded by carbon-carbon double bond. Next, option D is the right answer, and option B is also a right answer, but I'm marking option D as a right answer, right? Thank you. Which of the following is a vicinal dihalide or Wick dihalide? The options are given as follows. Right? A vicinal dihalide means, yes, I will explain you what is a vicinal dihalide, and this is question 4 and not question 3 because it is a mistake by me. A vicinal dihalide is an organic compound in which the halogen atoms is attached to two adjacent carbon atoms, right? So 1,2 dichloroethane is one among the options, right? So let's write the structure. C bonded to Cl, bonded to C, bonded to Cl, and the other bonds are satisfied by hydrogen atoms. See, the chlorine atoms are bonded to two adjacent carbon atoms, right? So which is also called a vicinal dihalide or Wick dihalide. So option is B. Please remember this. The order of reactivity of the given alcohols is: the first is a primary alcohol, the second is a secondary alcohol, and third is tertiary alcohol, right? We have the options also. The order of reactivity of alcohols of alcohols is equal to, first comes the tertiary alcohols, which have the highest reactivity, next the secondary, and next the primary. So please remember this always in your examinations also. So according to this, we have the answer option C, which is C greater than B greater than A, which is given in option C. The major product in the reaction of Br2 with ethyl benzene in the presence of FeVr3 is, the options are given as follows. So let's take on the first reaction of this chapter. When Br2 reacts with ethyl benzene, in the presence of FeBr3, please look into this, FeBr3, right? We have the benzene ring. You know how to draw a benzene ring, right? Yes. Now ethyl benzene is the given reactant, CH2CH3 attached to the benzene ring, plus Br2 in the presence of FeBr3. Here Br2 is attached by a single covalent bond. Br is attached by a single covalent bond, and one bromine is utilized by FeBr3 to complete its octet, and the remaining is Br plus, which is an electrophile which remains. So, and this electrophile attacks ethyl benzene, right? And ethyl benzene, as we know, is an ortho para directing group or OP directing group. So the Br should get attached to ethyl benzene either in the ortho place or the para place, right? So the products are, we get two products, right? The major and the minor. So let's see which is the major product and which is the minor product. CH2CH3 attached to this again, and bromine get attached to the ortho position. Let's take ortho place first. CH2CH3 again, and let's attach it to the para position or the para place, right? So ortho compound, and this is a para compound. C is compound here, okay? So here in the ortho compound we have steric hindrance, right? So this ortho compound is not much favored, which means this ortho compound also becomes the minor product, right? Minor product. So this, in this para compound, no steric hindrance or it's very less, which is a major product. So option is C.